In this segment, I want to talk about algebraic data types and constructors. When we define a type like colour, we have the three values red and green and blue. These are called constructors because they are the things that construct values of that type. Now, these are very simple constructors in that they just construct a constant value, red, green and blue. But in general, constructors take arguments, and those are like the fields of a record. Let's look at an example. We can define a type people, where the values are of the form person applied to a name and an age. And as usual, we're deriving show and equality. Now I'm using name here as a synonym for the type string and age as a synonym for the type integer. So what we're saying here is that if we apply person to a string and an integer, we create something of this type, we construct something of this type people. So for example, if we apply person to electric Aunt Jemima and the age 77, we get one person. If we apply it to the string Ronnie and the age 14, we get another. So the values of this type are constructed by applying this constructor function person to a string and an age. But as we see, it's different from an ordinary function in that it begins with a capital letter. So there is an example of a different way of creating elements of a data type where we apply a particular constructor to values in other types. So this builds a person, somebody in the type people, by applying the constructor to a string and an integer. Now, how do we define functions over that type? Well, let's define one that turns a person, something of type people, into a string. And again, we use pattern matching. A general member of that type will look like person applied to a string, st, and an int n. So the argument to show person will be of the form person applied to st and n. And here st is a string and n is an integer. And we build that string that shows the whole person by joining st to a dash and then putting at the end of that a printable version of the integer. So if we want to show person applied to the person electric Aunt Jemima and 77, what we get out is a string containing electric Aunt Jemima, the dash, and then the number 77. And here we're using this plus plus operation, which I think we talked about before, which joins two strings together to form a longer string. So that's how we convert something of type people into a string. Now we could, I said that to start with, we derived a show for this. We got the system to build us a print function automatically. We could say, actually, I'd like to have my own show function. I don't want the derived version, please. And here's a way of doing it. We say, oh, I'm defining for myself an instance of show for the type people. And I'm saying I want the show function to be actually my function show person. So we've simply said show equals show person. And then when we ask for a value like person applied to electric Aunt Jemima and 77 to be evaluated in GHCI, it's going to use the show function I defined and deliver the result as you see it. It's not crucial that you follow this mechanism. I'm talking about instances and so on. I've labeled this slide as optional, but it's just to show you can wire into the system your own mechanism for showing some data. Now, how do data types compare to tuples. We could simply define a type people as tuples, as pairs of name and age. What I've done, so on the left hand column I'm saying let's have a new type called people, and they will be constructed by that constructor person. So the things in that type look like person, electric arc Jemima 77. Whereas on the right hand side I'm saying, well, let's just have a pair, and so we have a pair electric arc Jemima and 77. So why would we use one rather than the other? What about the data type definition? Well, one advantage of the data type definition, it explicitly labels the piece of data as a person. The things that belong in that type are person, electric arc Jemima 77. So we know it says it's a person. And that means it's harder to misuse, and it makes any error messages clearer. So it's easier to read, harder to misuse. Why? What are the arguments for not defining a new type? I think there are two, really. It's more compact. We're just using a pair. We don't have to name a constructor. And because we're just using a tuple, it's possible that we can make more reuse of existing code that works with pairs and so on than we could were we to define our own data type with its own constructor. So we might get more reuse, we might have more compact code with using the tuple option. The data type makes things more readable, harder to misuse, and potentially makes errors clearer. So it's a matter of a trade-off between the two, but it's something it's useful to you, for you to be aware of, the fact that there are these two ways that you could define something like a type of persons, type of people.